Welcome to another tech video from your very own The Tech Cult, powered by DeltaEdge Networks. In today's session, we are tackling a topic every network engineer aiming for CCNP or CCIE should master: MPLS Traffic Engineering and Fast Reroute for 2025. We'll break down TE fundamentals, RSVP-TE and segment routing differences, and real-world FRR scenarios you'll likely face in interviews. What interviewers expect. When interviewers bring up MPLS-TE, they're not just testing if you know what a tunnel is. They want to hear how you, 1. Use TE to optimize network utilization. 2. Handle link failures with minimal packet loss. 3. Understand how RSVP signaling, CSPF and FRR interact. 4. Compare RSVP-TE versus SRTE and design for scale. So let's start from the top. What exactly is MPLS Traffic Engineering? MPLS Traffic Engineering is about steering traffic through specific label-switched paths to optimize link usage and meet service-level constraints. Instead of relying solely on IGP cost, TE lets you build explicit or constraint-based paths that satisfy bandwidth and delay requirements. Interview tip: emphasize that TE separates traffic distribution from pure routing reachability. Next up, RSVP-TE Fundamentals. RSVP-TE is the signaling protocol that establishes TE tunnels. It uses path and RESV messages to reserve bandwidth and build label-switched paths across the MPLS domain. Remember, path messages travel downstream from head-end to tail, while RESV travels upstream. Mentioning this simple flow often earns points in interviews. What are traffic engineering attributes? Each tunnel includes attributes that determine its path selection. Common attributes include bandwidth, how much capacity the LSP reserves; affinity bits, to include or exclude certain links; explicit paths, manually defined node sequences. Interviewers often ask how you'd make sure voice traffic uses a low latency path. Your answer: set appropriate affinities and explicit constraints. Segment routing traffic engineering. Now let's contrast SRTE with traditional RSVP-TE. Segment routing removes the need for per-tunnel signaling state. Instead, it encodes the path as a stack of segment IDs. This improves scalability and simplifies control plane management. If asked, say RSVP-TE stateful, SRTE equals stateless and SDN friendly. CSPF computation. CSPF, constraint-based shortest path first, is what decides the actual path of an MPLS-TE tunnel. It takes IGP topology, applies TE constraints, and computes a feasible path. In interviews, you can explain that CSPF ensures both reachability and resource compliance, making it smarter than regular SPF. Bandwidth reservation and preemption. When multiple tunnels request resources, the router uses preemption priorities. Each LSP has setup and holding priorities. 0-7. A tunnel with a better priority can preempt another to grab bandwidth. If you're asked how you'd prevent voice traffic from being displaced, set voice LSPs with higher preemption priority. Fast Reroute, FRR. Fast Reroute or FRR provides near-instant recovery when a link or node fails. It pre-computes backup tunnels that activate within 50 milliseconds. Two main methods exist. Link protection reroutes traffic around a failed link. Node protection bypasses a failed node. Key phrase to remember: pre-signaled backups for sub-second failover. Traffic engineering tunnels and verification. When verifying MPLS-TE, mention commands like show MPLS trafficking tunnels, to list active LSPs, show RSVP interface, to check reservations, and ping MPLS-TE tunnel X for OAM validation. Interviewers want to hear that you verify both signaling and forwarding planes. Real interview scenario. Here's a common one. A primary TE tunnel fails, backup doesn't activate. What's wrong? Answer sequence. 1. Confirm FRR is enabled on all nodes. 2. Check for available backup bandwidth. 3. Verify CSPF actually computed a valid backup path. 4. Review RSVP logs for missing RESV messages. always end with, I'd simulate a failure to verify FRR switchover timing. To recap, MPLS-TE ensures optimal path utilization. RSVP-TE handles signaling. SRTE offers scalability. CSPF picks paths based on constraints. FRR keeps the network resilient with sub-50 ms failover. Understanding these together shows not just configuration skills, but network design thinking. If you found this helpful, download our MPLS-TE and FRR cheat sheet below. It's packed with commands, diagrams, and quick interview answers. Comment your toughest MPLS question. We might cover it next time. And don't forget to subscribe to the Tech Cult powered by DeltaEdge Networks. Next up, OSPF versus ISIS design scenarios for 2025. Another interview favorite. Thanks for watching and see you in the next one.